So here we got our quick video on 7.3. There's really not that much to teach in here. There's just one key thing. I'll say, make sure you can solve these types of questions. So just to start us off, you want to be able to say, okay, this is the hypotenuse, this is the adjacent, and so we do cosine equals opposite over adjacent, so you want to be able to make cosine theta equals not opposite over adjacent, adjacent over hypotenuse, 12 over x, and be able to pick that equation, be able to pick that really quick. Once you can set these equations up, actually solving them for different things is pretty much a breeze. So this is the type of question we want to work on. How do you find the measure of angle theta? Well, we're going to set up our equation first. We do not know what theta is, so we're going to have to identify our different sides and then use them to figure out theta. So we're going to make our equation. First, 15 is the opposite. This is the hypotenuse. So our equation is going to be opposite hypotenuse is going to be sine of theta equals opposite divided by hypotenuse, so 15 divided by 17.39. How do I solve this equation? Well, we want to try and get theta. So what do? I say I need to finally, unlike usual, separate these two. I need to undo this sine function that's getting done to the theta. How do I do that? There is a simple calculator button or function known as the inverse sine. There's also one for inverse tan and inverse cosine. And so what I'm going to do is I'm going to take the inverse sine of both sides of this equation. So I'll rewrite this real quick. I'm going to give us a little bit more space. So 15 over 17.39. And in red here, I'm going to do the inverse sine, which is written like this sine with a little -1 of it. And what I do to one side, I have to do to the other. So I inverse sine this. And these two are inverses of each other, just like squaring and square rooting, or addition and subtraction. These will undo each other, so the signs will cancel out, and you're left with just theta equals the inverse sine of 15 divided by 17.39. And that is the answer. Your calculator does have a button for the inverse sine. So if you go into your calculator and you find the inverse sine function, which looks like this, sine with a little -1, and again, that's pronounced inverse sine. There's also one for inverse tangent and so on and so forth. Divide it by 17.39. And you put this entire expression into the calculator. Or what you can do is do this divided by this and then take its inverse sine. And in this case, we get 59.6 degrees. And that tells us the answer. That's how many degrees this angle is. It's like magic. I'll show you a second one. Let's say we want to do this. We want to find the measure of theta. I identify this as being the... I'm going to just make up something here. I'm going to say this is 5 meters right there, because I want to show you that it doesn't have to be sine. So if we know this side is 5 meters, we know that's the adjacent. This is the hypotenuse, so we're going to use cosine. We're going to say cosine of theta is equal to adjacent over hypotenuse, so that'll be 5 divided by 6. Once the equation is set up, we just take the inverse cosine of both sides. That removes the theta from this side and gives us an inverse cosine on that side. And that's our answer, the inverse cosine of 5 over 6. Put that in a calculator and you get that theta is 33.6 degrees. We can always round this to the nearest tenth of a degree. Should be enough for this type of problem. Here are some word problem versions of this. Jerome is flying a kite on the beach. It's attached to a 150-foot string and is flying this far above the ground. So let's draw a picture to go with the story. We're flying a kite. Here is our kite. It's flying 43.7 feet above the ground, and it's on a 150-foot string. You can see the right triangle that is created here. And they say, what's the angle of elevation? Calculate the measure of the angle formed by the string and the ground. That is this guy, the string and the ground. The angle formed by the string and the ground. And this is called the angle of elevation. So what do we do with it? We're just going to call that theta. And now we set up our equation. This is an opposite. This is a hypotenuse. So we do sine theta equals 43.7 over 150. Take the inverse sine of both sides, and that will give us our answer in degrees. When you do sine inverse, it will take a ratio in and output a number of degrees. So in this case, I put this into the calculator, sine, making sure to close my parentheses. That's very important. Divided by 150, and I get that the angle of elevation is 16.8 degrees. And you'll select that as your unit degrees because you're not measuring it in centimeters square or something like that. It's an angle, so it's measured in degrees. Here's another example of our story problem. We have a 35-foot ladder. There's our ladder. It's 35 feet long. And it's leaning against the top of a building. The ladder's base is 11.5 feet from the building. Notice that here would be the building. And they say it's 11.5 feet away from it. Find the angle of elevation between the ladder and the ground. The angle between those is right here. So notice that this is the adjacent, this is the hypotenuse. And so cosine of theta is 11.5 divided by 35. So just pull the cosine inverse to the other side. And that's our answer. Inverse cosine of 11.5 over 35. And the answer is 70.8 degrees. And it already says degrees, so we actually don't need this degree symbol right there. 70.8 degrees. Jet takes off. So the plane, and it travels this many miles to achieve an altitude. When it says it travels 82.2 miles, that means the distance it actually goes through the air here is 82.2 miles. The altitude, which is how high up it is 49.47. I'm running out of space here, but you can see what we're trying to get at, 49.47. And they say, what is the angle of elevation? We would set this equation up as sine theta is 49.47 over 82.2, and then solve that equation for theta, and that would be our answer.